In this video, I'm going to show you how to use the calculator to obtain confidence intervals for a population proportion. I'm taking an example from section 9.3. I invite you to join me in the text and take a look at page 494, in particular, problem number 22. Problem number 22 is asking family values. In a USA Today Gallup poll conducted in November of 2007, 768 of 1,024 randomly selected adult Americans aged 18 or older stated that a candidate's position on the issue of family values are extremely or very important in determining their votes for president. Part A is asking, obtain a point estimate for the proportion of adult Americans aged 18 or older for which the issue of family values is extremely or very important in determining their votes for president. Now they're asking for p hat. And so to calculate this, we would just take x, which in this case is 768, and divide that by the sample size, which is 1,024. Now in this case, I'm getting a very nice decimal. It almost appears that the problem was cooked up. But so often when you do these types of problems, you will find that you don't get a very nice decimal. And we've talked before in the videos from Chapter 8 about propagating a round-off error when you're dealing with a population proportion. And you have to be very sensitive to that. So for this problem, it's not necessary. You can easily retype 0.75 and not propagate a round-off error. But for so many of the other problems, it is a real issue. And so the best way to field this would be just to store this result. And you can do that as follows. You just press the stow key and then pick a memory register where you want it, like alpha A, for example. And so then that value is stored there, and you can fetch it as needed and achieve the full precision of the calculator without having to retype. Now in this case, obviously you could retype, but anyway, other problems. It's very important to be able to do that. Part B is asking, verify that the requirements for constructing a confidence interval for P are satisfied. Well, there's a couple of conditions in particular, and they come from section 8.2. All of this that we're doing here with the confidence intervals is based on the central limit theorem. So if you can't apply the central limit theorem, then you really can't do the confidence intervals. So the first thing they want us to verify is that the distribution is bell-shaped enough. And so the way we would check that is we would take n times p hat times 1 minus p hat. And so the easiest way to do that here, since we've stored p hat in A, would be as follows. We take n, which is 1,024. We multiply that by alpha A, and then we multiply that by 1 minus alpha A. And in this case, we're getting 192, which is considerably larger than the 10 that we consider as a cutoff for normality checking here. So we're good to go on that. The other conditions that would need to be satisfied, we want to make sure that we're sampling less than 5% of the population. And the reason for that is it helps to maintain independence of the sampling. So I would say that, yeah, 1,024 is definitely less than 5% of the population of adult Americans aged 18 or older. So we're good to go on that as well, and we can apply the central limit theorem here. Part C is asking, construct a 98% confidence interval for the proportion of adult Americans aged 18 or older for which the issue of family values is extremely or very important in determining their votes for president. Now we're going to use the 1 prop z interval for that. And you can see it. You got to scroll down to find it there. Let's go down a little bit here. Right there, it's letter A. It's the 1 proportion z interval. So to select it, you can just press enter, and you can see exactly what it's asking for here. It needs to know what's x. Well, we were told in the problem that x is 768. And we need to know what's n. Well, we were told also in the problem that n is 1,024. And as far as the confidence level, we were requested to find a 98%. So we'll put 98% there, and we're ready to calculate. And the interval's right there. Part D is asking, is it possible that the proportion of adult Americans aged 18 or older for which the issue of family values is extremely or very important in determining their votes for president is below 65%? Is this likely? Two ways to answer this question here. One of them is to use the confidence interval that we have. And you can see that the confidence interval goes from 0.718 to 0.781. So another way to explain that would be to say that we're 98% confident that the true population proportion is contained between those two values right there, 71.8, or actually 71.9% if you round it to one place, and 78.1%. And so in that case, 65% is not contained by the interval. And so that would make it very unlikely. Now it's possible, but again, we're 98% confident that this interval here contains the true proportion. So definitely the probability that it would be 65% would be less than 2%. And so for that reason, I would say it's very unlikely. There are other ways you can tackle that. You could also apply the central limit theorem directly to do a normal CDF calculation, but that's a little bit more difficult, and it neglects the result that you have right here in front of you. Anyway, we hope that you find that helpful, and I have another video for you that covers an example from section 9.4.